J.J. Thomson was born in the city of Manchester. He was a bit of a child prodigy and started what is now known as the University of Manchester, just aged 14. However, most of his notable achievements came at his spell at Trinity College in the University of Cambridge. He is well known for his discovery of the electron in 1897. Thomson showed that cathode rays were composed of previously unknown negatively charged particles, which he calculated must have bodies much smaller than atoms and a very large value for their charge to mass ratio. J.J. Thomson did this by conducting a series of experiments. In his first experiment, he redesigned the cathode ray tube and introduced the vacuum element to what we now know as a cathode ray tube. By pumping as much air out of the tube, J.J. Thomson showed that the cathode ray itself could be affected by a magnetic or electric field. He thus proved that the ray itself had a charge. In his second set of experiments, J.J. Thomson proved that cathode rays had a negative charge. He did this by applying an electric field through two charged plates, one positive and one negative. He observed that the rays was always deflected towards the positively charged plate, and thus deduced that the cathode ray was indeed negatively charged. Finally, by recording the angle of deflection and measuring that against the applied charge, J.J. Thomson was able to work out a mass to charge ratio. In 1904, J.J. Thomson summarized his finding and observation in his plum pudding model of the atom. He suggested electrons are small, negatively charged, and these negative charges are distributed about a positively charged medium like a plum in a plum pudding. The negatively charged electrons would balance out the positively charged medium so that the electron would be neutrally charged overall. Although this theory was generally accepted, there were some amongst the scientific circle that had their reservation. One in particular was a Japanese physicist named Nagaoka. He rejected Thomson's model on the basis that opposing charges were impenetrable. In 1904, he proposed his own alternate theory. He suggested a planetary model of the atom in which a positively charged center is surrounded by a number of revolving electrons in the same manner of Saturn and its rings. This thought is the basis of the progression of our atomic model. Rutherford would later comment on Nagaoka's theory as a starting point for his alpha particle scattering experiment, which was conducted in the University of Manchester.